Hey everybody, we are here to do notes over 3.1 and 3.2. We have two main goals for the day. We want to be able to identify linear and nonlinear functions, and we want to be able to identify independent and dependent variables. So we're going to look at that in two different ways. We're going to start with the linear versus nonlinear. You're going to practice that a little bit. Then we're going to do some independent versus dependent. You can see that the notes are like a little goofy today, right? Because you can like actually see me. I'm really here. Here, I'll let you see me. Hi, I'm upside down. Bring it back down. All right. So notes, I'm actually going to be writing on here, and then you guys can write along with. You should have this 3.1, 3.2 notes, should say that right across the top. And we want to talk about linear functions, and then we want to talk about nonlinear functions. And how can we tell which one's going to be which? So, first, let's look at graphically for a linear functions. We're going to work our way across with linear, then we're going to work our way across with nonlinear. When I have a graph, I always have an x and y plane. And a linear function is pretty easy because it's just anything that goes in a straight line. So here's my x and y coordinate. So I could have a line that goes like this, straight across. I could have one that goes up at an angle like this. I could have one that goes down like this. I could have any variation of these, so some might be steeper than others, but as long as it's a straight line, it is linear. Now, one that is not linear would be one that is straight up and down. That's not okay, because that's not a function, right? We're talking about linear functions, and this would not pass a vertical line test. Therefore, this one would not be a function, but these other three would be. Oh, so I probably shouldn't put that there. So there's our three types of linear functions we could have. Now, if I saw a linear function on a table, I'll do an example of that. Like if I have, I'll do two examples. I could have an x and a y. And I could have numbers like -1, 0, 1, 2. And then I could have y values like 3, 1, -1, -3. Now what I want to look for here is the relationship. You guys have been talking about this all week. You're like, yeah, function, linear function, I know what to look for. And it's been awesome to see, but here it is. So we need to look at our x values and make sure that they go up by the same value. So this one, to get from -1 to 0, I did +1. From 0 to 1, I did +1. From 1 to 2, I do +1. Then I look here, what did I do to get from 3 to 1? Well, that's a -2. What do I do to get from 1 to -1? Well, that's also -2. And from -1 to -3, that's also -2. So these three being the same and these three being the same tells me this is a linear function. Sometimes we have vertical tables that look like this. It's the same idea, it's just sideways, right? What we could also have, though, is I could have a linear function that has -4, -1, 2, 5, and then I could have y values of 0, 1, 2, 3. And what I see here is this goes up 3 to get from -1 to 2, and up 3 to get from 2 to 5. Those are all three the same. Then I also have to check the y's to make sure that they are the same. These go up by 1s. If my x values go up by different amounts, then I'm not going to have a linear function. If my y values go up by different amounts, I'm not going to have a linear function. So make sure we notice that. These three the same, these three the same, these are the same, and these are the same. I could have more points, and then I would need to have more of the same. Even if I have 50 points here on my table and goes all the way down, if one of them breaks the rule, it's not a linear function. Now for an equation. Equations like this we talked about in class about how they always follow that y equals mx plus b, or you may see it as y equals b plus mx. And m and b for these are always just numbers, so it could be like y equals 2x minus 7, right, where m is 2 and b is negative 7. I also want you to be aware that I could have one where like m is 1 and b is 0. So let's think about that. Y equals 1x, which is just x. Oh, I'm a little off. 1x, which is just x, plus 0. So y equals x is still a linear function. So make sure we notice that they don't have to all have m's and b's, because b is 0, it's gone. Okay, so that's what we're looking for. Those are our linear functions. How about some nonlinear functions? So for our graph of nonlinear functions, there are so many different ways that I can draw a line. The biggest thing to know is that it has to curve at some point, or no, just has to curve at some point, sorry. So there's a curve, so it's nonlinear. You could also have one that curves just like this. That's like x squared. That one's nonlinear. I could have one that goes straight for a really, 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 really long time and then curves. If there's any bit of it that curves, that is nonlinear. It doesn't go in a line. So some tables that we have when we have nonlinears. I'm going to do 3 straight up and down tables. Is if anything changes. So here I could have -2, 0, and 2. Well, these go up by 2. That's nice. But then when I go to my y values, what if I have -1, 0, 2? Well, here this goes +2, +2. So my x values pass the test. But my y values go +1, +2. They're not the same. So that tells me that one's non-linear. Here, what if I have my y values are all like -3, -1, 1. Well, that's nice. They go, yep, here I'm going +2, +2. But then here, what if I have like 0, 9, 13? Well, +9 and then +4? No, that does not work. So this one would also be non-linear. Last but not least, I could have one where my x values are -1 and then 9 and then 1. This one goes up 10 and then it goes down 8. That doesn't work. We can't do that. And it doesn't matter what the y is. If you have x values that aren't working, don't even check the y because they don't work. Equations. Here we're looking for kind of some oddities. Like what are some weird things that we could put in equations? For example, we could have anytime I have in any of the problem, any point, if I have x and then I have a number up here other than 1, like 5 or x to the -2 or x to the 1/2, all of these, as soon as I see them, I will label this as a nonlinear. It's nonlinear as soon as I see those. Another thing I could see is some fractions, like 1 over x. Anytime I would have 1 over x like that, then I would know that that's nonlinear. Okay. So let's take a look at some examples here. This is your time to try some. So I want you to try these 3. Go ahead and pause the video, or these 6 I mean, and go ahead and pause the video. Okay, so we need to identify, are they linear or nonlinear for all 6 of these? This one, I have a curve. It's not just a straight line, so this one is non-linear. This one is a straight line. I don't see any curve in it, and it's not going straight up and down, so this one has to be linear. Here, I look at my x values first. They're all going up 1, so that's pretty easy. +1, +1, +1. Then I look at my y values. I go +3, +3, +3. Oh, That works for both. So this one is linear. Here, I am going up by 1 each time. That's promising. And then I go here, and I'm going, okay, go down 1, then go up 1, then go up 3 more. That is all over the board. That's a no-no. So this is non-linear because it's changing in such a goofy way. And you can kind of see the relationship here between our non-linear table and our non-linear graph. I'm going to graph this on this graph. And we can kind of see how it wouldn't be a straight line, it would be a curved line, okay? So let's take a look. If I put -1, 0 on here, -1, 0 is right here. 0, -1 is right here. 1, 0 is here. And then 2, 3 is here. Now with these 4 dots, there's no way I can connect these with one straight line like this. I would either have to curve like this, or I could do like straight lines between them, but that's still not a linear function. Now we have our equations. Are they linear or are they nonlinear? Linear or nonlinear? Let's see. So this one, I can write this as a y equals mx plus b. I've got no fancy exponent up here. I've got no x in a denominator, so this one is linear. Here, I've got this x to the 3rd power. That's an exponent. That means this one is non-linear. Okay. The next section, we're actually going to switch back to where we're doing it on the computer. So I'm going to bring that up. So here we have our independent variable is what we can change, and our dependent variable changes if the independent changes. So let's take a look. The score on a test and the amount of time that you studied. Which one of these changes the other one? So I'm going to color code these. My independent, I'm going to call red. My dependent, I'm going to make blue, sorry. So which one of these changes the other one? The score on a test and the amount of time you studied. Well, my score is dependent on how much time I studied. The weight of your dog and the reading on the scale. Well, the reading on the scale is dependent on the weight. Now these are kind of tricky because, well, they're just 2 variables to us, but we really need to think in this. We need to sit down and think about it. What one changes the other one? Does the weight of our dog change the reading on the scale, or does the reading on the scale change the weight of your dog? Think about that. Does the dog look at the scale and then suddenly be like, oh, I'm a 300-pound dog, and then get really fat? No, that's not how that works. The number of times you dip a wick into hot wax and the thickness of a homemade candle. The thickness is dependent on the number of times that you dip. The more you spend on advertising, the more product you will sell. The more you spend, the more product. So the product is dependent on how much you spent on the advertising. Last but not least, the more students who help to decorate for the homecoming dance, the less time it will take to decorate. So time it will take to decorate is dependent on the number of students. These ones are tough because you just really got to think about them. There's no like equation or formula. You need to think about what variable really changes the other variable. Your homework is actually a worksheet, so it's got some some graphs on there, and then on the back there's some that are just like this. You got this, guys. I believe in you.